All right, everyone. Thank you so much for coming to our workshop. We're going to be discussing exploratory data analysis in Python. We've got some people in Zoom and some people in person too, so I'll try and look back and forth the best that I can. So both of us, I'm Katie and this is Roni. We work for the Statistical Consulting Lab. So I'll just start with an introduction about our lab. So we're located in Gilbreth Hall in the offices on the third floor in 308T. So if you have any questions or need help with any sort of statistical research, feel free to come by there during our operating hours listed below. We also have a YouTube channel where you can find all of our past workshops, and this workshop will be on there hopefully by tomorrow when we get done. And then down at the bottom of the slide here is our email, so you can reach out to us at scl@etsu.edu as well if you don't got time to come by the office. So there's a couple different ways that we can help you. So first of all, we provide free consulting on research design, statistical analysis, and data management. So this semester, there's currently 3 consultants, and between all of us, we're proficient in Python, R, SAS, and Stata. And we are happy to help guide you on how to use that software. So just to give kind of 2 different examples, you can see below, the first example was when we assisted a faculty member with research. So they had a challenge brainstorming proper methodologies to analyze survey data. So our role is we suggested related techniques to that one. And this is just an example, but we can help with pretty much any statistical questions you might have. So case 2 was a student assignment, and it doesn't have to be an assignment. It could be student research, whatever the statistical question may be. But their challenge was understanding regression analysis and how to use statistical software. So we gave learning experiences and guided model selection and interpretation. Okay, so to get right into it, we're going to do a quick background of Python before we move on to the hands-on section. So Python is a computer programming language often used to build websites and software, automate tasks, and analyze data. And that's what we're going to be doing today is the data analysis. So Python was first released in 1991 and created by Guido van Rossum. So it started as a hobby project for him during the holiday season. And he named the language after the BBC comedy series Monty Python's Flying Circus because he wanted a name that was short, unique, and a little mysterious. So if anything, this knowledge will help you in trivia. Okay, so we'll go ahead and get right into the hands-on practice. If you would, go ahead and go open Colab. I'm going to do the same. Can you go to the Zoom for me? Okay. Is everyone that wants to follow along, are they at this screen? And I can go ahead and explain. If you need us to wait, just say something in the chat. Okay. Okay, so if you're on this screen, what we're going to do is click upload, and then we're going to browse. And then wherever you saved the file that I sent out in the email, you're just going to click on it and open it up in here. Okay, and once you do that, you should see the file that I sent you yesterday. But we also need to upload our data. So to do that, once you get this uploaded, we're going to go over here and click on this files icon. Okay. Now we're going to hit the little upload button. And now this is the empty cars data set that I also sent in the email yesterday. And we're going to open that. and you could just ignore this. Okay. Was everyone able to get to this point? If you need a few minutes, just let me know. Where's the files icon? Okay. So this right here, this is the files icon on the left bar. So if you click on that, it opens this little window here, and you click on the upload button, and you can upload your data.
Someone asked for the Jupyter file.
Okay. Kevin, did you register for the workshop? If you were registered, it should have been sent in an email yesterday.
Yeah, I registered, but I think I didn't receive that. I've checked my email. I didn't see it. So I have to register again. Like I have to use my Gmail to register and get that and get into the meeting.
Okay.
Okay.
Unmuted. Mute.
1 second, please. All right, sorry about that. Kevin, if you would just send your email in the chat on Zoom, my colleague here is going to email it to you real quick with the data.
When I tried to upload the MT cars file, I got an error message.
Was
Says,
it the warning message?
unexpected token M model MPG is not valid JSON syntax error.
When you downloaded it, did it stay a CSV file?
I believe so. Let me look. It's on my desktop. Yes.
Okay. Can you just paste your error into the chat real quick so I can see it? I might not be able to help right this very second, but I'll see if I can. Go back to the chat real quick, would you? I have no idea. Okay. Okay, my colleague's going to work on that and see if he can figure that out. I'm really not sure. Maybe if you can try and just re-upload it again. Have you only done it the one time, or have you tried again?
Sorry, I didn't know I had muted back. I've tried it a couple of times and keep getting the same error message. But if you can share your screen so I can see what you're doing, I can just try to follow along.
Okay. Okay, well, I'll just do that. I'm sorry. I'm not sure what the issue is with that one, but I'll go ahead and just keep my screen shared, and if you have any questions or anything, you can just stop me.
Okay. Well, so far you're not sharing the screen. I just see you.
I'm not sharing the screen.
No. Well, I'm if you are, I'm not seeing it. I'm just seeing you.
I can share your screen.
Okay. Are you able to pull up Zoom full screen and see if you could see it? Because I think everyone else is able to see the screen at the moment.
Okay, hang on. I'm in full screen, but it's showing me the gallery view at the moment.
Okay. Well, unfortunately, I don't think I can do much to help you from this end, but I will say that this whole workshop is going to be recorded. So if you aren't able to get it figured out in the next couple minutes, feel free to just watch it on YouTube later if that's okay.
Okay.
All right, thank you. Okay, so let's go ahead and get started. So first, exploratory data analysis, or EDA, is a fundamental step of the process of working with data. Before starting your analysis or modeling of any data, first that data must be explored. And explorations let us know what's in the data, what the data looks like, any trends or patterns that might better inform your analysis, as well as any problems or inconsistencies that must be dealt with. So we know what we're going to be talking about, so I'm going to skip these next two paragraphs. But here is a little bit of an outline that this Jupyter notebook is going to walk us through today. So before getting started, we want to make sure that we know our data. So the MTCARS dataset is a very popular dataset that comes with R. So you don't even, if you're working in R, you don't even have to upload that as a CSV or anything like that. You can just use a function to call it because it comes with R. But here we will walk through uploading the data. So we need to know how it was collected, what do each of the variables mean, who collected this data, and what is the data source. So then we're going to go through and explore the data file. Okay, and then we want to prepare our data set for the exploratory data analysis. So this is going to include importing libraries that are going to help us manage the data and plot different plots that could help interpret the data. So we're going to load it. Then we want to check that the data has been loaded correctly. We'll clean the data, and then we're going to check for missing values and also explain how to deal with those missing values. And then finally, we're going to talk about actually performing the exploratory data analysis. So we're going to do a deep dive into the numerical variables and then the categorical variables, and also explore the relationship between both of them, because that'll be important when modeling. So then we'll perform an in-depth data analysis using statistical tests, and finally, we're going to assess your modeling goals. Okay, so first of all, we want to know our data. So the data here, like I said, it comes with R whenever you install R, but you can also get this in a CSV version on Kaggle. So if you follow this link here, you can find the place where we downloaded it. So just looking at the data file, I went ahead and wrote out this little data dictionary in this table below. So we have 32 observations and 11 columns, or 11 variables. So let's start with some of them are self-explanatory. It's a data set about cars. So MPG is miles per gallon. That's going to be a numeric continuous variable. CYL is the number of cylinders in that car, and it's either 4, 6, or 8. Displacement, disp is the displacement of the engine. It's a continuous variable. Horsepower, continuous. DRAT is the rear axle ratio, and it's also continuous. Weight, you've got weight, the weight of the car, continuous. CUSEC is the quarter mile time. So it's the time to run 1/4 of a mile from a standing start, and it's also continuous in seconds. So VS is the engine type, and it is a categorical variable, and it is encoded in binary. So Whenever you see the number 0 in this column, it means that there is a V-shaped engine, or if you see a 1, that's a straight engine. Okay, and then the next variable is AM, and that is going to stand for the transmission type. And again, it's categorical. So if you see a 0, that's automatic. If you see a 1, that's a manual. And then finally, we've got gear, which would be the number of gears, and then carb, which is the number of carburetors. So now that we have a decent understanding of our data set, let's go ahead and go into importing our libraries. So pandas and NumPy are two very, very popular libraries that are used for data management and analysis. And this matplotlib and seaborn, these are both libraries used for plotting, and they make really nice plots. Okay, so with that, let's go ahead and run that. And by the way, to run on Google Colab, I'm pretty sure on most IDEs you can use Shift-Enter. But anyways, if you want to run this, a keyboard shortcut is to go ahead and click Shift-Enter, and it will run for you. Okay, so moving on, we're going to load our data. And we want to name this data car raw. So this PD is, like I said a second ago, it comes from the pandas library. So it just helps you read in a CSV into this Jupyter notebook. So let's go ahead and run that. Okay, and now that we ran that, let's just check and make sure that we imported this correctly. So this .head function here is going to let us look at the first 10 rows of the data set. So let's see what we got. So this shows the model of the car, and then we can see all of the variables and columns we discussed earlier in the data dictionary. And it looks like it loaded correctly because remember VS was a categorical variable. You got zeros and ones, same thing for AM, zeros and ones. So, okay, then let's just do a sanity check on the shape because we said there was 32 rows and 11 columns. So let's just make sure that's right. And it looks like that's right. And that's what that dot shape function does. Now, the inUnique function, that's going to check the counts of unique values per column. So let's run that. So the model, there's 32 different models. So each of the observations is a different model. And it makes sense for VS and AM to only be 2 because they were binary categorical variables. Okay, now the variable model is unique, and you can tell this because there are 32 values and there is only 32 observations in total. So it's unique, so we can go ahead and drop that because we don't need it for the analysis. So that's what this next little block of code is going to do. So now it's the same thing we saw before, except we don't have the model column. Okay, next we're going to go into the important part. Before we do that, let me just see if there's any questions or anything. Nope, okay. All right, so we're going to go into checking for missing values. So we can check, and if the data does not have missing values, we can go ahead and jump into the next step of analysis. We don't even have to worry about that. But if the data does have missing values, we got to figure out what we're going to do with them. In this case, the data does have a couple missing values. So there's a couple different ways that you can handle them. The first and just clean cut, easy way to do it is dropping the column or dropping the rows with the missing values. But sometimes you don't always want to do that. Sometimes you might need the other information that's in that column or in those rows. So then we could impute the missing values if that's what we wanted to do. So how do we choose what to do? So first, we're going to check the proportion of our missing values per column. So if the proportion is low, i.e. less than 5%, we can drop the rows with the missing values or impute using simple methods like mean, mode, or something like that. If the proportion is moderate, we should impute using advanced methods such as mice imputation. If the proportion is high, we should drop the column because imputing can compromise the nature of the data. And that's why you do have to be careful when imputing, but we're going to talk about the different things that we could do. So, okay, if we choose to drop, we could drop the values of columns. If we choose to impute, we got to check the missing data pattern. And here's a little list of the different types of missing data patterns. And then finally, we'll check the variable properties. They should be the same before and after imputation. Okay, so this little block of code here is going to check the proportions of missing values. Okay, so we can see that the DISP, which was our displacement, our engine displacement, has 12.5% missing values. And then our AM, which was our transmission, has 6.25% missing values. So now we know that our percent of missing values is greater than 5%. So we're going to go ahead and look at the missing data pattern. Okay, so what this shows you is where exactly the missing data is in comparison to the rest of the data. So what you can see by this plot is if you line up these white blocks, it doesn't seem that where a value of displacement is missing, a value of the transmission is missing. So we have 4 separate missing values over here and 2 separate missing values over here. And it doesn't seem like much, but whenever you only have 32 observations, that will really hike up the percentage of missing values. So let's focus on this AM, the transmission variable first. So if we choose to drop the rows, we can just run this code here. So this first block of code, all I'm doing is making a copy of the data frame we created before, except now I'm giving it a new name so I could do other work on it without messing up the first one. Okay, so let's run that. And now we want to see the shape of this. It's the same as before, except now 10. Oh, it was 10 because we removed the model as well. So that makes sense. And now we're going to run this code that will let us drop the AM rows with missing values. And you can't really see it here, but let's run this next one. Okay, so now this was before we dropped this shape here, the 3210. And then since we had 2 missing values in the transmission column, we just got rid of those 2 rows completely. So now that tells us we have 30 rows and 10 columns. Okay, but if you decide that maybe you're going to need those 2 rows, which is possible, then we could choose to impute. So let's run this code here and go ahead and make another copy of the car raw data frame that we made above. Let's run this here. And so now let's see, this is telling us the frequency of responses in the data. So what that means is, let's recall that 0 means automatic transmission, 1 means manual transmission. So this means that 59% of the data is automatic transmission. 34% of the data is manual transmission. So clearly we can see that the automatic transmission is the most frequent value. So what we're going to do is we're going to replace the two missing values with automatic transmission. Now, if you think about it, before, this is kind of just for example's sake, because if we left in the model column, we could probably just go and look at the car and see if it has an automatic transmission. So this is just for example purposes, but that would be the way to do it if you were actually working on this data set. Okay, so we filled in those missing values with 0. And now that we did that, we can see our frequencies changed a little bit. So we went from 59% automatic transmission to 65% of automatic transmission. And moving on. Okay, and yeah, the distribution is slightly changed, but again, this is going to be due to your small sample size. Usually when you're doing EDA, you're working with much bigger data and there's a little bit more flexibility. So let's move on to dealing with the missing values in the DIS or displacement, engine displacement variable. So let's see. This code here just tells us the data types of each variable. So some of the data types are incorrect. For example, transmission has been read as a numerical, but it is categorical because remember it was encoded as 0 and 1. So we definitely need to change that. So let's see the data types. And this code here will change categorical variables and also the two discrete variables to an object. So now that we got that fixed, we can look at summary statistics and distributions. This will be useful to get to know the properties of our data, and it is important that they remain consistent after imputation because you don't want to lose the integrity of the data set. I can't read that. Okay. So let's see, where was I? Okay, so now let's look at, this is just showing us our numerical variables now. Okay, cool. So where I change those data types, I can now see the numerical variables here. Okay, so now using this describe function, it shows you the count of each variable. So this makes sense, this value here. We've got the count of disp is 28. Well, that makes sense because earlier we saw that we have 4 missing values in this column. Okay, and we should also look at the distribution of the variable to be imputed. So this is gonna make a plot for us. So let's run this. So by the way, this code is getting probably a lot more complicated than where we started, but I wouldn't worry too much about this because with AI and everything now, you could just put in, hey, please make me a histogram, and it spits it out for you. And it can help you make it pretty and have it look however you want to look. So this code, I know it's getting a little bit more complicated, but don't worry about it too much. Okay, so the histogram shows our distribution of the data here. And so most of the values are in this 100 to 150 area. And then we've got the rest of the values being 150 and up. So sometimes people would use simple techniques to impute missing values, such as imputing the mean, which is just replacing the missing values with the mean of that column. But again, that's something that we should be very careful with because they can alter the nature of the data, and then our analysis would be unreliable and it wouldn't actually give us any true results. So we observed that the proportion of missing values was moderate, so we should not use simple methods like that. And here's why. So all this code does here is it's filling the missing values in the displacement column with its mean. So just for example purposes, so we can show you what it does to the statistics. Okay, so here is before, and let me try and zoom out so we can see both. Okay, that's good. So this top here is before we replace the missing values with the mean, because we have 28. And now this bottom one, we replaced all the missing values with mean, and now we have 32 values. So the mean stayed the same, but our standard deviation changed, our 50th percentile changed, 75th, 25th, and let's see. And then the min and max would stay the same. But you could see just by adding those couple values that, you know, relate to the center of the data, it changes the statistics a lot. So then let's go ahead and see the distribution after we imputed. Okay, so we still have that most of the values are here, but if we remember these values between 250 and 300 were much higher than these values here between 150 and 200. So if we go back up and see what it looked like before we imputed, this was our distribution before. Okay, now since we imputed the mean, we have many more values that are going into this column here. Okay, and so as we can see, the summary statistics and distribution have been affected by the imputation, and thus it is not reliable. So let's explore if the relationships between numerical variables show any promise for imputation. Note, these should also remain consistent before and after the imputation. So we're going to go ahead and use this SNS and PLT before this code. These are just referencing the libraries that we imported earlier, so the matplotlib and the seaborn libraries. So if we run that, we're going to get a nice heat map. And what we're looking for in this is two variables that are highly correlated, because what we want to do is use a variable that's highly correlated with displacement to be able to predict those missing values using a simple linear regression model. So here's our displacement variable. You can see that displacement and miles per gallon have a strong negative correlation. Okay, but let's go across and see if we see anything stronger. Of course, displacement is going to be 100% correlated with itself. Horsepower, about a 78% positive correlation with horsepower. That's good. Drat, I can't remember what that one was, but it's got a mildly strong negative correlation with drat. Okay, but then we see weight, and weight has a very strong positive correlation with displacement. So let's go ahead and use this weight variable here to see if we can predict the missing values within the displacement column. Okay, so this is a big block of code, but basically all we're doing is performing simple linear regression. So this first line up here is going to be importing the library that we need to do that. And then we want to make another copy of the data frame from earlier. So then we want to filter out rows where disp or displacement and weight are not null. So that would be the train set. And then this will help us perform the linear regression because we're setting our independent and dependent variable. So displacement is obviously the variable where we want to fill in those missing values. So that's why that's our dependent variable. So then we create and fit the linear regression model. That's all this code does here. We want to predict missing values in displacement. So that's what these 3 lines of code do here. And then finally down here, this will replace the missing values with the predicted values. So let's go ahead and give that a run. Cool. So it just did all that I just talked about. And now let's check the shape. And it's 32, so that's good. Okay, now this little bit of code here is going to tell us if we have any missing values in any of the columns. So now that we filled in the missing values in displacement, we have 0 missing values throughout any of the columns. So we're good to go. Now let's go ahead and look at some statistics before and after imputation. Okay, so let me see if I can, there we go. So it's a good bit of change. I wouldn't say it was as much as previously when we just used the mean, but still there is a little bit of change. And truthfully, that's just something that you're going to see whenever you're replacing missing values in a data set that's relatively small. So there's only 32 observations. Like we saw earlier, 4 of those values was 12.5% of the entire data set. So it's bound to change whenever you're working with a small sample size. And then we will look at the correlation before and after imputation. So before, we know that displacement was highly correlated with weight. And as it is here, but it's a little bit higher. You want the correlations to remain relatively the same. But again, when you're working with small data, it's hard to keep the values exactly the same as before. So that's just something to keep in mind. So we'll look at histograms again though. So one thing you can notice though about the distribution is, remember when we compared before and after imputing with the mean of this column, our distribution remains nearly the same. Let me see if I can zoom out even more. Okay, so the top one is before, the bottom one is after. There's still a little bit of differences, like this column got a little bit bigger, but it's much closer to the original than when we tried to impute using the mean. So that's good. Okay. Let me zoom back in here. All right, guys, give me just 1 second. I'm gonna get a Okay, and with that, I'm going to go ahead and pass this over to my colleague, Roni, and he's going to walk us through the rest of performing the EDA. Just leave your laptop here.
I need to see it. Okay. Done. Hi, I'm Ronnie. So now we're going to talk about more exploratory data analysis. So first, we create the copy of the data that we already imputed. So for the first one, so if you look at the code here, we are creating the subplot for our figures. So it's going to be a 2x3. So it's going to be a 2x3 matrix. So here we can see all the numerical variables and their histogram. So to draw histogram, the main code is this line. So we are using the SNS library, and from that one, we're just using the histogram. And this is a common pattern or common template for loop in Python. So here we are using for I and X enumerate. It means that our code is gonna look at the MPG, displacement, horsepower, and weight, and axle ratio. And this enumerate is gonna tell the for function to go in those places that to look for those values like MPG displacement. Also is gonna keep the index number. So this way, first we're gonna draw the MPG, the displacement, the horsepower, the axle ratio, the weight, etc. So we can see that our MPG is right skewed. That means the most of the cars MPG falls between roughly 15 to 25. Okay. And this is also right skewed. It's like heavily right skewed. So the displacement is like from 100 to 200. Only few are there more than 400. And similar for the horsepower, the most cars are falls between 100 and 200 horsepower. Only few are them more than 200 horsepower. So we can also see this using boxplot. So what boxplot gonna show us is gonna show us the outliers. So if we see, okay, before that, to plot the boxplot the same way, we are just gonna use the SNS library and we're gonna use boxplot function. Okay. So if we look at the MPG, we can see the medians are from 15 to roughly 22, 23. Most of the cars fall in that range, but we can see there is one outlier in there. It's like close to 34. Also for horsepower, and it also confirms our histogram that most falls between 100 to almost 200, but this one shows the outlier in the horsepower. Same way for our weight, we have few outlier in there. So boxplot just shows that in what range most of our variables are, and what if there is any outlier, what might it be. Next. So this is a pair plot. So we are drawing or we are plotting variables with pair. So if you can see that here we have MPG, displacement, horsepower, and axle ratio, weight, and quarter mile speed. Also on the x-axis, you can also see the same thing. So that way, control right to zoom out. So that way you interpret this plot. So you look at the MPG. Also, you look at the y-axis MPG. You also look at the x-axis. Okay. So on the diagonal, it just shows that histogram. So this is the histogram for a quarter second. This is the histogram for weight. This is the histogram for horsepower. So on the diagonal, this way, it only shows our histogram. But if you want to look the correlation or the relation between the mile, the MPG and displacement, you interpret it like this. So you go MPG is there, all this row are MPG, and so MPG is there, this one, and if you go at the column, you see displacement. So this one is for MPG, displacement versus MPG. Does that make sense? So if displacement goes higher, that way it goes higher, then we can see the MPG is get lower. Okay, so on the x-axis we have displacement. If you go down there, we can see displacement. On the y-axis we have MPG. So this is our MPG and this is our displacement. Okay, so we can see if the displacements go higher, our MPG goes lower. It goes this way. If we pick another one, let's see. If we took horsepower and displacement, so this is our horsepower and this is our displacement. So if we go there, you can see if the displacement get higher, our horsepower is also gonna get higher. Okay, so this is our x-axis. For x-axis, we go down there, display, and for the y-axis, we go there. Okay, so this is how we interpret the pair plots.
Add something.
Yes.
Okay, I just have one thing that I want to add to this plot. This is really helpful for when you're going to do simple linear regression or even multiple linear regression, because looking at these plots, you can see if it might need a quadratic term or some interaction term to help with multicollinearity or anything like that. So let me find an example. Okay, so usually people working with this data set, the target is miles per gallon. So they want to see if they can figure out with all these other features, are they able to see what the miles per gallon is going to be? So if we look at the plot of miles per gallon and weight, as miles per gallon is increasing, the weight is decreasing. And this makes sense because the heavier the car that you have, the less miles per gallon that you're going to get. So that's just something I wanted to add so we can see actually interpret some of the results. Let me zoom back in for you. There you go.
So this is our data, numeric DF. Now we're going to see few numerical statistics. So this function does that. Dot, if you have any data, this is the name, then you can just put describe and parentheses. So it shows you this 5-point summary, the statistic summary of the data. And this dot T is just for the display. It just transpose the matrix. It just make the row column and column row. So you don't actually, most of the time, you don't even need this one. So all you need, if you have any data, you just write dot describe, it will give you the 5-point summary. Okay. So if we look at this one, means how many of this count, like how many of this variable is in the data. So if there was missing value, as KD showed us, so there was missing value in this one. Okay. So is before the imputing, we didn't change it here.
Yeah, go back up. So there was you might want to, if you're running this, you might want to change this in your code. There's one typo where we meant to put a 3 instead of a 2. So if you change that to the 3, that's going to use the data frame that we did the imputation on. That should be, it should run fine now. All right.
Okay.
And now it should show 32 in the count column for displacement. Yep.
Yes. So as I was saying, if there was any missing value, you could still see it in there. So we can see all of this, our MPG, displacement, horsepower, they all have 32 points in there. So this shows the mean of our MPG, and it is 20 mile per gallon. This shows our standard deviation. This shows our mean, and this shows our quartile. We have 3 quartile. So this is the first quartile, or 25%. So it means that all the value fall of 15.4 falls less than 25%, and 75% of the value falls after that values. Okay. So we can see for displacement, the mean is this, and the standard deviation, and the minimum. If you look at the minimum and maximum, so it's really widespread. So sometimes, not all the time, sometimes this is not a good indication of the data because it's widespread. So similarly, we can see the weight, their mean, standard deviation, and etc. So here we can also see this count in frequency table. So we have categorical variable. So categorical variable has sometimes 2 options or like 3 options. So for our cylinder, we have 8, 4, or 6 cylinder car. So if we see, we have 14 8-cylinder car, we have 11 4-cylinder car, we have 7 6-cylinder car. Okay, so this is just the frequency table, how many times each of this category happens. That was the meaning of frequency table. So this is for the automatic 18, and the manual is 14. So we have 18 cars which are automatics and 14 cars which are manual. So we can also see this visually using bar plot. So here, the same thing we just saw earlier with number, and here with bar plot. So we have 6-cylinder engines, like 7 or 8, like 7, 4, we have 11 or 12. For 8-cylinder engine, we have around 14. Okay, it's the same thing, but with bar plot, sorry. So we can also establish what kind of relationships our categorical and numerical variable have. For example, so here we are using our automatic, how many car we have automatic and what's their MPG is. Here we can also see, okay, which car with the displacement, what is the displacement of automatic and manual car, stuff like that. Okay, we can go to the next one. Similarly, for this one, we are using gear because, okay, I must say for the previous one, so we are using the categorical variable AM with all the numerical variable. Here we are doing the same thing with gear. with all the numerical variable, because gear is the categorical and we are comparing it to all the numerical variable. So for the gear, same, the MPG is 21 to 28, and for 4 is like what, 15 to 16. So sometimes it's not really easy to see from the graph, because you can make this graph like individual. Here we have what, 6 graph. You can make them each individually if you don't use this subplot. Okay, so if you just plot it, you will see they are more like large, with large display, and you can see, okay, you can see this number more visually, like more. Okay, we are also doing the same thing here. We can also add more like second categorical variable to see, but the principle is the same. So here we are using this function group by to group our data just using this AM categorical variable. So here we can see the automatic and the manual card. So it's gonna show us the MPG, all the numerical variable with respect to this automatic, this categorical variable. Okay, so if you look at this one, the automatic, for all the automatic card, the MPG is 21, and for all the manual card, our count MPG is the standard. Sorry, the mean is 23, and for the automatic is 18. So same way we can do this for displacement. So the same way we can do for weight and quarter second. Okay. So here all we are doing, we are just dividing all the numerical variable with respect to our categorical variable. And for this, we are just using this function group by. Okay. We can use the same way here, we use the automatic or manual. We can use the same way the gear function, the gear or categorical variable. The principle is the same. Here we can also get our horsepower and gear, and we can also see, okay, so if we have 3 gear in our car, the horsepower, the mean, and for the gear 4, the horsepower mean, etc. So is the basically the same thing that Katie showed us before. So if you don't want to discriminate between categories, we can also compute this summary statistics for the entire set. Okay. So this is a contingency table. So we can see the gear with respect to automatic. So if you have 3 gears, all of these cars are automatic. So no car with 3 gear is manual, which makes sense. So for 4 gear car, we have 6 automatic and 6 manual car. And for 5 gear, all of the 5 gear cars are manual car. Does it make sense? So this is what contingency table shows us. And you can actually create contingency table almost for everything. You can just do this it's easier to see when you want to compare 2 categorical variable. Sometimes you can do it like more than 2 categorical variable. It's just hard to interpret. So the same way, also we can also describe some statistics like chi-square statistics. So here we are just using this function to do the chi-square test. So this is not the main focus of our workshop. But if the P is low, then the null hypothesis must go. So because the P value is less than 0.05, we can conclude that there exists an association between the variables. We need this one because when we want to do the linear regression, because if we want to do the linear regression always has few assumptions. If two variables are highly correlated, the linear regression model is not going to give you an accurate result. So I have no idea about this test. So it's just a way of showing, okay, you can use this test to run. But that's not the point of this workshop. Okay, we can also use few modeling. So, but to do the modeling, we also look at variation inflation factor, BIF. So if BIF, as you can see, is BIF is 1, then there is no multiclonality. Actually, if it's less than 10, we can use the data to use linear regression or other kind of predictive modeling. But if it's like really high, we don't want to use those variable or use that data to using like linear regression to predict other variables. So here we use random forest regressor. So this is not actually an EDA, this is predictive modeling. So when you do this kind the predictive modeling, you can see, okay, what variable is most important to predicting something. So we use random regressor to predict our MPG. So we can see, okay, the weight is the most important variable to predict that variable, to predict MPG. And the gear is not that important, but weight is like really important. So that's for future discussion. So we use other modeling like multiple linear regression, XGBoost, and those kind of model. So this concludes our workshop.
Yeah, sorry for going a little bit over. I'm just going to pull up our survey page. Oh, it's not letting me escape. Okay, so if you have time, that will conclude our workshop. Just go ahead and fill out the survey for us if you can. I'm going to pull up the chat and see if there's any questions. So if you have any questions, just go ahead and put them in the chat and we'll stick around for a little while and fill out the survey if you got time. Thank you all for coming. I'm going to go ahead and stop recording.
Does anyone have any question?
I'm just stopping recording, but I'm going to leave it open for a little bit.